Hello dear students, in this video we will see the previous year questions and the questions from sample papers from chapter 8, which is linear programming problem. Now this chapter, it has a weightage of 8 marks. So we will see the previous year questions followed by the sample paper questions from last year and this year. So here we have the first question. Maximize z is equal to 3x plus 4y if possible, subject to the constraints x minus y less than or equal to minus 1, minus x plus y less than or equal to 0, x comma y greater than or equal to 0. So here we have to find the feasible region which satisfies all these constraints. If there is a feasible region, then we can maximize z, and if it is bounded. So first let us take a graph sheet and let us have points say 1, 2, 3, 4, here 2, 3, 4, and here let us have minus 1. So first we have to draw the lines corresponding to x minus y equal to minus 1 and then minus x plus y equal to 0. So this is nothing but x is equal to y. So for this, when we put x as 0, y is 1, and when we put y as 0, x is minus 1. So here we have 0 comma 1 and here we have minus 1 comma 0. Now if we draw a line joining these 2 points, we will get x minus y equal to minus 1. Here the region corresponding to x minus y less than or equal to minus 1, say if we substitute the origin and check, when we put x and y as 0, 0 it is not less than minus 1, it is more than minus 1. So the region corresponding to x minus y less than or equal to minus 1, it is the open half plane not containing the origin. So this is the region for x minus y less than or equal to minus 1. And now let us draw the line corresponding to x equal to y. Now we know for x equal to y, it is a straight line which passes through the origin and has a slope of 45 degrees. So here when x is 0, y is 0, let us take any point say 2 and 2. So here we have 0, 0 and here we have 2 and 2. If we draw a line joining these 2 points, we will get the line corresponding to x equal to y. So here we have minus x plus y less than or equal to 0. Here we cannot substitute the origin and check. Instead we can substitute any point say 1 comma 0. So 1 comma 0, if we substitute here, we have minus 1 plus 0. This is less than or equal to 0. As a result, the open half plane on the other side, this side, this corresponds to minus x plus y less than or equal to 0. And next we have x greater than or equal to 0. So it is this part. So here we can see that this linear programming problem, it has no common region at all which satisfies all these constraints. That is, it has no feasible region. As a result, since there is no feasible region, the given LPP has no solution. So this is a question for 2 marks. Now moving on, the next question, a dietitian wishes to mix 2 types of foods F1 and F2 in such a way that the vitamin content of the mixture contains at least 8 units of vitamin A and 10 units of vitamin C. Food F1 contains 2 units per kg of vitamin A and 1 unit per kg of vitamin C, while food F2 contains 1 unit per kg of vitamin A and 2 units per kg of vitamin C. It costs rupees 5 per kg to purchase food F1 and rupees 7 per kg to purchase food F2. Based on the above information, answer the following question. First, we have to formulate this as an LPP and then we have to determine the minimum cost of the mixture. So first let us write what is given and then let us form the constraints. After that, let us solve this question. So here let us take that the mixture contain x kg of food F1 and y kg of food F2. So here if we take food F1 and food F2, here we have the vitamin requirements, vitamin A and vitamin C. So here it is given food F1 contains 2 units per kg of vitamin A and 1 unit per kg of vitamin C. So this contains 2 units per kg of vitamin A and 1 unit per kg of vitamin C. And next we have food F2. It contains 1 unit per kg of vitamin A and 2 units per kg of vitamin C. And then here the minimum requirement given is there should be at least 8 units of vitamin A and 10 units of vitamin C. So here the requirement is for vitamin A it is 8 and for vitamin C it is 10. And then the cost per kg of food F1 it is rupees 5 and cost per kg of food F2 it is rupees 7. So we have taken let the mixture contain x kg of food F1 and y kg of food F2. As a result, we have to minimize the total cost. So minimize z is equal to 5x plus 7y subject to the constraints. First we have the constraint for vitamin A. Subject to the constraints 2x plus y greater than or equal to 8, and next we have the constraint with respect to vitamin C. X plus 2y should be greater than or equal to 10, and we have the non-negative constraints x comma y greater than or equal to 0. So this is the formulation of this given linear programming problem, which is the first part. And the second subdivision we have to determine the minimum cost of the mixture. So here let me write it here. Minimize z is equal to 5x plus 7y subject to the constraints 2x plus y greater than or equal to 8, x plus 2y greater than or equal to 10, and x comma y greater than or equal to 0. So first let us draw the line corresponding to 2x plus y equal to 8. When x is 0, y is 8, and when y is 0, x is 4. So here let us take the scale as 1 centimeter equal to 1 unit. So here we have 0, 8 and 4, 0. So this is 0, 8 and this is 4, 0. So if we draw a line joining these 2 points, we will get the line corresponding to 2x plus y equal to 8. But here we have 2x plus y greater than or equal to 8. So it is the open half plane not containing the origin. So it is this part. This is 2x plus y greater than or equal to 8. And next we have the next constraint. So first let us draw the line corresponding to x plus 2y equal to 10. When x is 0, y is 5, and when y is 0, x is 10. So here we have 0, 5 and here we have 10, 0. If we draw a line joining these 2 points, we will get x plus 2y equal to 10. Here we have x plus 2y greater than or equal to 10. So it is the open half plane not containing the origin. So it is the other side. So this is x plus 2y greater than or equal to 10. And then next we have the non-negative constraints x comma y greater than or equal to 0. So here x greater than or equal to 0 it is this part, and y greater than or equal to 0 it consists of the first quadrant. So the feasible region consists of this part. It is this part. So this is the feasible region. So this is the feasible region. So now let us mark the corner points of the feasible region. So this is one corner point A 10, 0. This is another corner point B. This is another corner point C 0, 8. Here we can see that this corner point B we can we can see the points, that is the coordinates for B from the graph itself. It is 2, 4. If we are not able to find the points, we can solve these two equations and find the coordinates for B. Since here we are drawing it on a graph sheet, we can see that the coordinate for B is 2, 4. And now let us find the value of Z at these corner points. So the three corner points are A 10, 0, B 2, 4 and C 0, 8. Here we have Z is equal to 5x plus 7y. So here the value of Z is 50 and then here the value of Z is 10 plus 28, which is 38, and then here the value of Z is, we put x as 0, y as 8, so 8 sevens are 56. Here we can see that the minimum value is 38. So this is minimum. Now here, since this feasible region is unbounded, we have to find the region corresponding to 5x plus 7y less than 38. If this open half plane, if it passes through this corner point without interfering the feasible region, then this given linear programming problem will have an optimal solution. But if this open half plane, if it interferes the feasible region, then this given linear programming problem will have no solution. So for that, first let us find the region corresponding to 5x plus 7y less than 38. So let us draw the line 5x plus 7y equal to 38. So here when x is 2, y is 4. Then for the other point, let us take when y is 0, x is 7.6. So we already have this point P 2, 4, it is here. Then 7.6, 0, it is somewhere here. If we draw a line joining these 2 points, we will get 5x plus 7y equal to 38. The region corresponding to 5x plus 7y less than 38, it is the open half plane containing the origin. So it is this part. It is this part. So here we can see that here this region, it does not interfere with the feasible region and it passes through this corner point B. As a result, this point B, it minimizes Z. Since the feasible region is unbounded, we draw 5x plus 7y less than 48. Since this open half plane does not interfere with the feasible region and passes through B 2, 4, the given LPP has an optimal solution at B 2, 4. Hence, the cost is minimum when the dietitian mixes 2 kg of food F1 and 4 kg of food F2, and the minimum cost is equal to rupees 38. So this is the minimum cost. So here in this year's sample paper, a similar question is given for 5 marks. So here formulating the problem, that is writing the constraints and the objective function, all these carries 1.5 marks. Then drawing the graph carries 2 marks. Then finding the value of Z at each of the corner point and writing the result. All these carries 1.5 marks. So a total of 5 marks for such questions. Moving on, next question. The feasible region of the LPP minimize Z is equal to 5x plus 7y subject to the constraints 2x plus y greater than or equal to 8, x plus 2y greater than or equal to 10, xy greater than or equal to 0 is given below. Determine the optimal solution and justify your answer. So here we can see that the feasible region for this linear programming problem, it is given here. Here we can see that the feasible region is unbounded. Since the feasible region is unbounded and here since it is a minimization problem, we have to find the half plane corresponding to 5x plus 7y less than minimum value of Z. So for that, first let us find the minimum value of Z using these corner points. So here we have 3 corner points, B 10, 0, C 2, 4 and L 0, 8. and here z is equal to 5x plus 7y. So here it is 50. For C 2, 4, the value is 10 plus 28, 38, and then for L 0, 8, the value is 56. So this is the minimum value. Actually, this question is from a different paper. So here we have the same formulation which we had for the previous question. Here we can see that the minimum value of Z, it is 38 and it is attained at C 2, 4. Now we have to draw the half plane corresponding to 5x plus 7y less than 38. So here when x is 2, y is 4, then when y is 0, x is 7.6. So this point is 2, 4, and then we have 7.6, 0 somewhere here. If we draw a line joining these 2 points, we will have 5x plus 7y equal to 38. Now the region corresponding to 5x plus 7y less than 38, it is the open half plane containing the origin. So it is this part. So here we can see that this open half plane, it passes through C 2, 4 without interfering the feasible region. Since the feasible region is unbounded, we draw 5x plus 7y less than 38. Since this open half plane does not interfere with the feasible region and passes through C 2, 4, the given LPP has an optimal solution at C 2, 4, or it attains an optimal value at C 2, 4. Hence, the optimal solution is x is equal to 2, y is equal to 4, and optimal value z is equal to 38. So this is the optimal solution and this is the justification. This is a question for 2 marks. Next question, a diet for a sick person must contain at least 4000 units of vitamins, 50 units of minerals and 1400 units of calories. 2 foods X and Y are available at a cost of rupees 4 and rupees 3 per unit respectively. 1 unit of food X contains 200 units of vitamins, 1 unit of minerals and 40 units of calories, whereas 1 unit of food Y contains 100 units of vitamins, 2 units of minerals and 40 units of calories. Based on the above information, answer the following question. To minimize the cost of the asset, formulate the above problem as an LPP and determine the number of units of each food required to satisfy the requirements. So here, based on the information which is given, first let us formulate the given linear programming problem. Let us take, let the mixture contains X units of food X and Y units of food Y. So here we have food X and food Y. Food X, it contains vitamins, minerals, calories. So food X contains 200 units of vitamins, 1 unit of minerals and 40 units of calories. Whereas this food Y contains 100 units of vitamins, 2 units of minerals and 40 units of calories. The minimum requirement is there should be at least 4000 units of vitamins, 50 units of minerals and 1400 units of calories. So this is the requirement. All these are in units. And here we have the cost of food 1 and food X and food Y. So it is rupees 4 and rupees 3. This is cost per unit. All these can be written in the rough. It is enough if we just write the formulation alone on the far side. So here we have taken the mixture contains X units of food X and Y units of food Y. So we have to minimize the cost. minimize z is equal to 4x plus 3y subject to the constraints. First, we have the constraints with respect to vitamins. So 200x plus 100y greater than or equal to 4000, or this is 2x plus y greater than or equal to 40. And next we have the constraint with respect to minerals. So x plus 2y greater than or equal to 50, x plus 2y greater than or equal to 50. And next we have the constraint with respect to calories. 40x plus 40y greater than or equal to 1400, or this is x plus y greater than or equal to 35. Then we have the non-negative constraints x comma y greater than or equal to 0. So this is the objective function and these are the constraints. So here we can write minimize cost z is equal to. So this is the formulation, this is the answer for the first subdivision. Now let us determine the number of units of each food required to satisfy the requirements using graphical method. So let me write it here. We have minimize z is equal to 4x plus 3y subject to the constraints 2x plus y greater than or equal to 40, x plus 2y greater than or equal to 50, then x plus y greater than or equal to 35. So first let us draw the line 2x plus y equal to 40. Next we have the non-negative constraints. So here when x is 0, y is 40, and when y is 0, x is 20. So here let us take 1 unit as 1 centimeter as 10 units. So we have 0, 40 and 20, 0. So if you draw a line joining these 2 points, we will get 2x plus y equal to 40. The region corresponding to 2x plus y greater than or equal to 40, it is the open half plane not containing the origin. So that is 2x plus y greater than or equal to 40. And next we have x plus 2y equal to 50. When x is 0, y is 25, and when y is 0, x is 50. So we have 0, 25 and 50, 0. So let us draw a line joining these 2 points to get the line x plus 2y equal to 50. But here we have x plus 2y greater than or equal to 50. It is the open half plane not containing the origin. So it is this part. It is x plus 2y greater than or equal to 50. And next we have x plus y greater than or equal to 35. So for that, when x is 0, y is 35. When y is 0, x is 35. So let us mark 35, 0 and 0, 35. Let us draw a line joining these 2 points so that we get x plus y equal to 35. Here we have x plus y greater than or equal to 35. So it is the open half plane on the other side of the origin. So this is x plus y greater than or equal to 35. Now the region which is common to all these, it is this part. And next we have the non-negative constraints, it is the first quadrant. So the region which is common to all these, it is this part. So this is the feasible region. And now let us write the corner points. This corner point is a 50, 0, and this corner point here from the graph itself we can find it is b 20, 15. And next we have this corner point C. It is 5, 30. And finally, we have the corner point D, 0, 40. So these are the 4 corner points. We have A 50, 0, then B 20, 15, then C 5, 30, and then D 0, 40. Now let us find Z at each of these corner points. So at 50, 0, it is 4 into 50, 200. Then at B 20, 15, it is 4 into 20, 80, plus 15 into 3, 45. So it is 125. And then at 5, 30, it is 4 into 5, 20, plus 3 into 30, 90. It is 110. And here 0, 40, it is 3 into 40, 120. So here we can see that this is minimum. Now here we can see that this feasible region is unbounded. So since the feasible region is unbounded, we draw the line corresponding to 4x plus 3y less than 110. Since it is a minimization problem, we have to find the region corresponding to this and check whether it crosses the feasible region or not. So for 4x plus 3y equal to 110, one point is 5 and 30. We can take this point itself since this point satisfies this equation. So one point is 5 and 30. Another point we can put y as 0 so that we will get x is equal to 27.5. So here we already have 5, 30 here, and then 27.5, 0, it is somewhere here. So if we draw a line joining these 2 points, we will get this line 4x plus 3y equal to 110. This 4x plus 3y less than 110, it is the open half plane containing the origin. So it is the other side. So it is this part. So here we can see that this region, it passes through this corner point C 5, 30 without interfering the feasible region. As a result, this given linear programming problem has an optimal solution. So here since the feasible region is unbounded, we draw 4x plus 3y less than 110. Since this open half plane does not interfere with the feasible region and passes through C 5, 30, the given LPP has an optimal value at C 5, 30. Hence cost is minimum when the diet has 5 units of food X and 30 units of food Y. 30 units of food Y. And the minimum cost, it is rupees 110. So this question can be expected for 5 marks this year. Writing the formulation carries 1.5 marks. Then drawing the graph carries 2 marks. Then finding the value of Z at each of the corner points and the result carries 1.5 marks. Now moving on. Next question, the feasible region of the LPP minimize Z is equal to 3x plus 2y subject to the constraints 2x plus y greater than or equal to Z, x minus y greater than or equal to 0, x greater than or equal to 0, y greater than or equal to 0 is given below. So this is the feasible region. We have determined the optimal solution and justified the answer. So first let us find the value of Z at the corner point, at these 2 corner points. And then since again it is the feasible region is unbounded, we have to find the half plane corresponding to 3x plus 2y less than minimum value of Z. So here we have the corner points P 2, 2 and Q 3, 0. So for P 2, 2, value of Z is 10 and for Q 3, 0, the value of Z is 3 into 3, 9. So this is minimum. Now let us draw the line 3x plus 2y less than 9. So when we have one point when x is 3, y is 0, when x is 0, y is 4.5. So we already have 3, 0 here. Then 0, 4.5 will be somewhere here. If we draw a line joining these 2 points, we have 3x plus 2y equal to 9. Now 3x plus 2y less than 9, it is the open half plane containing the origin. So it is this side. So here again we can see that this line passes through Q3, 0 and this region, it does not interfere the feasible region. As a result, the optimal solution for this LPP is x is equal to 3 and y equal to 0. So the smallest value of z is 9. Since the feasible region is unbounded, we draw the graph 3x plus 2y less than 9. As this open half plane passes through Q3, 0 without interfering the feasible region, the corner point Q3, 0 minimizes z. And minimum value of z is 9. Optimal solution is x is 3 and y is 0. So this is a question for 2 marks. Moving on, next question. S&D Chemicals produce 2 products, an alkaline solution and a base oil, that are sold as raw material to companies manufacturing soaps and detergents. On the basis of current inventory levels and estimated demand for the coming month, S&D's management has decided that combined production of alkaline solution and base oil must be at least 3,500 gallons. Then S&D Chemicals are committed to supply 1,500 gallons of alkaline solution to one of its major customers. The alkaline solution and base oil requires respectively 2 hours and 1 hour of processing time per gallon. The total processing time available for the coming month is 6,000 hours. The production cost is rupees 200 per gallon for alkaline solution and rupees 300 per gallon for base oil. Formulate the above as an LPP and solve it by graphical method to help S&D Chemicals determine the minimum production cost. This question and the previous question are from last year's sample question paper. So here the most important thing given is production cost is rupees 200 per gallon for alkaline solution and rupees 300 per gallon for base oil. So we have to minimize the production cost. So for this, let the company produce x gallons of alkaline solution and y gallons of base oil. And let z be the production cost. So our objective is to minimize z is equal to, here cost is rupees 200 per gallon for alkaline solution and rupees 300 per gallon for base oil. So it is 200x plus 300y. And here it is given S&D's management has decided that combined production of these, it should be at least 3,500 gallons. As a result, we need to have x plus y greater than or equal to 3,500. So this is the first constraint, subject to the constraints. So this is the first constraint. And next it is given S&D Chemicals are committed to supply 1,250 gallons of alkaline solution to one of its major customers. So as a result, we have x greater than or equal to 1,250. So this is the second constraint. And next we have the alkaline solution and base oil requires respectively 2 hours and 1 hour of processing time per gallon, and the total time available is 6,000 hours. The next constraint we have is 2x plus y less than or equal to 6,000. So this is the third constraint. And finally we have the non-negative constraints x comma y greater than or equal to 0. So here this is the formulation of this given linear programming problem. Now let us solve the linear programming problem. So the objective function and the constraints are written here. On a graph sheet, let us take the scale as 1 centimeter equal to 1000 units. First let us draw the line corresponding to x plus y equal to 3,500. So when x is 0, y is 3500, and when y is 0, x is 3500. So here we have 0, 3500 somewhere between these two, 3000 and 4000, and here we have 3500, 0. If we draw a line joining these 2 points, we will get x plus y equal to 3500. Now, the region corresponding to x plus y greater than or equal to 3500 is, it is the open half plane not containing the origin. So this is x plus y greater than or equal to 3500. And next we have x greater than or equal to 1250. So for that, let us draw the line x equal to 1250. It is a straight line passing through 1250, 0 and parallel to the y-axis. So this is the line x greater than or equal to x equal to 1250. X greater than or equal to 1250 is this part. So this is x greater than or equal to 1250. And next we have 2x plus y less than or equal to 6000. So for that, first let us draw the line 2x plus y equal to 6000 when x is 0, y is 6000, and then when y is 0, x is 3000. So here we have 0, 6000, and here we have 3000, 0. A line joining these 2 points. It is 2x plus y equal to 6000, but we have 2x plus y less than or equal to 6000. The region, it is the open half plane containing the origin. So it is this part. So this is 2x plus y less than or equal to 6000. Now the region which is common to all these, it is this small triangle. So this is the feasible region. This is the feasible region. Here our work is easier because the feasible region is bounded. Now if we draw this on a graph sheet, we will be able to get the corner points directly. So here, if we take this corner point as A, it has coordinates 1250, 2250. This corner point B, it has coordinates 1250, 3500. And this corner point C, it has coordinates 2500, 1000. On drawing this on a graph sheet, these coordinates can be obtained easily. Otherwise, we can solve the corresponding two equation of the lines and get the corner points. Now we have found the 3 corner points. Now let us find the value of z at these 3 corner points and find which corner point optimizes, that is minimizes z. So we have the 3 corner points A 1250, 2250, then B 1250, 3500, and C 2500 and 1000. So the value of Z, 200 into 1250 plus 300 into 2250, it is 9,25,000. Then for this 200 into 1250 plus 300 into 3500, it is 13 lakhs. And next we have 200 into 2500 plus 300 into 1000, it is 8 lakhs. So among all these, this is the minimum value. So this is minimum. As a result, minimum cost is rupees 8 lakhs when 2500 gallons of alkaline solution and 1000 gallons of base oil are manufactured. So here in this year, we can expect this question for 5 marks. Formulating the given linear programming problem carries 1.5 marks. Drawing the graph carries 2 marks. And then finding the value of z at the corner points and writing the result, it carries 1.5 marks. And now we will move on to the questions from this year's sample question paper. In the given figure, what is the LPP shaded region known as? So here we know that this shaded region, it is called the feasible region. So the correct option is option A. Next question. A book publisher sells a hardcover edition of book for ₹72 and a paperback edition for ₹40. In addition to a fixed weekly cost of ₹9,600, the cost of printing hardcover and paperback editions are ₹56 and ₹28 per book respectively. Each edition requires 5 minutes on the printing machine, whereas hardcover binding takes 10 minutes and paperback takes 2 minutes on the binding machine. The printing machine and the binding machine are available for 8 hours each week. Formulate the linear programming problem to maximize the publisher's profit. So here it is given a book publisher, he sells hardcover edition for ₹72 and paperback edition for ₹40. The fixed weekly cost is ₹9,600 and the cost for each is 56 and 28. Here we have to maximize the publisher's profit. So here we have to maximize the profit, but here the sales and the cost is given. As a result, first we have to find the profit to write the objective function. So let us take, let the number of hard copy and paperback copies be X and Y respectively. So the hard copy is X and the paperback copies is Y. So profit, it is given by sales minus cost. So here sales is 72X plus 40Y minus cost is, the cost of printing hardcover is ₹56. So the cost of printing one hardcover edition is ₹56. So X hardcover editions will be 56X minus cost of printing one paperback book is ₹28. So Y paperback copies will be 28Y. And then we have a fixed cost of 9,600 minus 9,600. So this 72 minus 56, 16X plus 12Y minus 9,600. So here the objective function is maximize profit. Z is equal to 72X plus 40Y minus 56X minus 28Y minus 9,600. So this is equal to 16X plus 12Y minus 9,600. Subject to the constraints. Now we have the constraints with respect to printing. Here hard copy requires 5 minutes and this paperback copy also requires 5 minutes. So this is in minutes, 5 and 5. And next we have binding. Hard copy binding takes 10 minutes and paperback binding take 2 minutes. And then it is given the printing machine is available for 80 hours and binding machine is also available for 80 hours. But here we have all these in minutes. So here the availability is 80 into 60, which is 4,800, and here also 4,800 minutes. So we have the constraint with respect to printing. Subject to the constraints, 5x plus 5y less than or equal to 4,800. This when we simplify we get it as x plus y less than or equal to 960. The next constraint is with respect to binding, 10x plus 2y less than or equal to 4,800 or 5x plus y less than or equal to 2,400. So these are the two constraints, and then we have x comma y greater than or equal to 0. So this is the formulation of this linear programming problem. This is a question for 2 marks. And now let us move on to the next question in this year's sample question paper. Rahul is at the wholesale market to purchase folding tables and chairs to later sell them at his furniture shop. He has only rupees 5,760 to spend and his van has space to carry at most 20 items. A table cost him rupees 360 and a chair cost him rupees 240. Back at his shop, he plans to sell a table at a profit of rupees 22 and a chair at a profit of rupees 18. Given that he can sell all the items that he purchases, how many tables and chairs shall he purchase in order to maximize his profit? So here we have to find the number of tables and chairs which Rahul should purchase to maximize the profit. So let the number of tables be x and chairs be y respectively. So we have to maximize profit. Z is equal to 22x plus 18y. Now we have the constraints, subject to the constraints. First we have the constraint with respect to space. His van has space to carry at most 20 items. So first let us take the constraint with respect to space. So x plus y less than or equal to 20. This is the first constraint. And next we have the constraint with respect to cost. He has only 5,760 to spend. Table cost him rupees 360 and chair cost him rupees 240. So 360x plus 240y less than or equal to 5,760. So this, when we simplify, we get it as 3x plus 2y less than or equal to 48. So this is the second constraint. And then we have the non-negative constraints, x comma y greater than or equal to 0. So this is the formulation of this given linear programming problem. Now let us draw the graph. So first we have x plus y less than or equal to 20. So first let us draw the line x plus y equal to 20. When x is 0, y is 20, y is 0, x is 20. So here let us take 1 centimeter as 5 units. So here we have 0, 20 and 20, 0. Let us draw a line joining x-axis and y-axis. Let us draw a line joining these two. For x plus y equal to 20, x plus y less than or equal to 20, it is the open half plane containing the origin. This is x plus y less than or equal to 20. And next we have the next constraint, 3x plus 2y less than or equal to 48. So when x is 0, y is 24. When y is 0, x is 16. So now let us mark the points. 0, 24 is somewhere here, and then 16, 0 is somewhere here. A line joining these 2 points. We will get 3x plus 2y equal to 48. The region corresponding to 3x plus 2y less than or equal to 48, it is the open half plane containing the origin. So it is this side. This is 3x plus 2y less than or equal to 48. As a result, the feasible region is, and then we have x and y greater than or equal to 0 is the first quadrant. So the feasible region is this part. This is the feasible region. So here we can see that the feasible region is it is bounded. So the maximum value of z will occur at one of the corner points. Now let us mark the corner points. Here we have A 16, 0, this is B, and this is C 0, 20. So for the coordinates for B, if we draw it on a graph sheet, we will get it directly as 8, 12. Otherwise, we can solve these two equations. We can solve x plus y equal to 20 and 3x plus 2y equal to 48. This, when we multiply by 2, we will get 2x plus 2y equal to 40. So from this, we get minus x is equal to, when we subtract, minus x is equal to minus 8 or x is equal to 8. From here, when x is 8, y is 12. Y is 12. So the coordinates for B is 8, 12. So these are the coordinates for B. If we are not able to get it directly from the graph, we can solve these two equations like this and find the coordinates for B. So we got these three corner points. 4 corner points including the origin. Now let us find the value of z at these corner points. So here the feasible region OA, BC, O. It is bounded. So we have the corner points and then the value of z, 22x plus 18y. So here we have O 0, 0, then A 16, 0, then B 8, 12, and then C 0, 20. So at the origin 0, 0, value of z is 0. Then at A 16, 0, the value of z is 22 into 16, 352. Then at B 8, 12, the value of z is 22 into 8 plus 18 into 12. So this, when we simplify, it as 392. Then at C 0, 20, the value of z is 360. So here we can see that 392 is the maximum. So the optimal solution is x is equal to 8 and y is equal to 12. So the optimal value of z occurs at corner point B 8, 12. Therefore, buying 8 tables and 12 chairs will maximize the profit, and maximum profit is rupees 392. So formulating this given linear programming problem carries 1.5 marks, drawing the graph carries 2 marks, then finding the value of z at each of the corner points and writing the result carries 1.5 marks. A total of 5 marks for this question. I hope this video was useful for you. So far I have solved all the previous year questions chapter wise in my previous videos. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.